Hello everyone, welcome to my channel.
Now let us discuss 𝗖𝗋𝗃 reaction. When there is a condensation reaction takes place between an aromatic aldehyde or ketone and an aliphatic aldehyde or ketone in presence of dilute alkali, then first forms an intermediate product which further on heating in presence of dilute acid forms the final product, that is your alpha beta unsaturated compound. And this reaction is known as your 𝗖𝗋𝗃 condensation reaction or 𝗖𝗋 condensation reaction. Now what happens here? Here the condensation reaction takes place between an aromatic aldehyde and an aliphatic aldehyde. Suppose the reaction occurs between benzaldehyde and acetone. Maybe your aldehyde or ketone, maybe two aldehydes. Okay. Now when benzaldehyde treated with acetone in presence of the dilute alkali, then there is what happens here. There is a condensation takes place due to which, जैसे हम डिस्कशन पहले कर रहे थे, यहाँ पे C double bond OH, one hydrogen alpha hydrogen will go to this position, it becomes CHOH, and that will attack to this position CH2 COCH3. See here, CHOH CH2 COCH3. Then on heating, again there is a water molecule removed from here, one hydrogen from here, one OH group here. So here one H2 molecule is removed, and the product is your benzyl acetone. This is your benzyl acetone. Now another important point is aliphatic esters containing alpha hydrogen atom also undergo 𝗖𝗋𝗃 reaction. That means instead of acetone, if you will take one molecule of benzaldehyde and another molecule of any example of any ester, but one important point is that ester should contain one alpha hydrogen atom, then also this reaction 𝗖𝗋𝗃 reaction is possible. Okay. Now let us discuss another important reaction, that is intramolecular aldol condensation or aldol cyclization. Why it is called intramolecular aldol condensation? Because this is only one molecule in which there is two aldehyde molecules are there, and the condensation will take place in between this molecule only. In this one molecule only there is a condensation takes place. That is why it is called intramolecular condensation. And aldol cyclization means after condensation it will form a 5 or 6 membered ring, due to which a cyclic product, you will get a cyclic product. That is why it is known as your aldol cyclization. Now let us see what is the mechanism, how the cyclic product will be formed. See here. Now first of all, what happens, one alpha hydrogen, if this one is your functional group, this is your alpha hydrogen atom. Okay, see here, this is your alpha hydrogen atom. Okay, now first of all it will form an enolate ion, but treatment with dilute alkali it will form an enolate ion. That means this hydrogen will be removed and it will form a enolate ion. So how will we write this? See here, this one is your CH2, C double bond OH, this is single bond CH2, this is your CH minus, this is your enolate ion. Okay, then this is your CHO. This is the formation of enolate ion. Okay. Now what is the next step? That enolate ion will attack to the carbonyl carbon of another aldehyde molecule. So see here what happens, this will attack the carbonyl carbon of this, and now this carbon becomes pentavalent, this goes to this position. So it form, now it will this form a product. What will the product? It's intermediate product, that is your, see here, CH2 single bond CH2 C, this is your H, this is single bond O minus. Okay, and now this bond will this position means this is your CH2 CH. See here, where the bond there is a attachment occurs between these two. Okay, this will attack to this position. So now see here, now there is a CHO group. Okay. Now when it is treated with, after the formation of this compound, when it is treated with water molecule, it will takes a proton, that means H2O, and in which it will take a proton H plus ion to form OH and the minus of OH minus, right? So the product form is CH2, CH2, C, this one is your OH, okay, this is your H, and this is CH2, this is your C. Now see here, this compound, here it is this compound. If I'll write this one HCHO, if I'll write this CHO, this position CHO, right? And now there is a bond, okay, there is a bond to this, and here the hydrogen, here suppose this is the hydrogen, okay. Now here what happens, after the formation of this compound, when we heat this compound, then there is a removal of water takes place, okay. Now see here how water remove takes place here. Now this bond goes to this position, so here there is a double bond occurs, and now this OH minus goes to this position. So there is a H plus and OH minus, so there is a removal of water molecule. So what will be the final product you will get? CH2, single bond CH2, here it is CH2, single bond C, and there is CHO molecule, CHO, right? Now here there is CH, and in between these two there is a double bond, okay. This one is your final product. Now what is the name of this compound? This is a what type of, this is a cyclic compound. This is a cyclic compound having 5-membered ring, 1 2 3 4 5. So what is the name of this compound? It's 𝗖𝗿𝗶𝗀𝗏, and one double bond is there, matlab suffix is E, okay. So the name is 𝗖𝗿𝗶𝗀𝗏 1 ENE, and the aldehyde group is there, that is where the special suffix is carbaldehyde, okay. 𝗖𝗿𝗶𝗀𝗏 1 ENE carbaldehyde, okay. So see here, finally after the cyclization, aldol, that means after the intermolecular condensation, the product form cyclic compound, that means 5-membered ring, and this is your mechanism of intramolecular aldol condensation, okay. Similarly, let us discuss another compound. Let us discuss this compound. This is an example of aldehyde. An intramolecular condensation occurs between a molecule where two aldehyde functional groups are present. Now we will discuss another example where there is 2 ketone functional groups are present, okay. 2 ketone functional groups are present. Now see here, first of all, when this is treated with an alkali, what will be the product? Same case, here also there is a enolate ion will be formed. So suppose here there is a enolate ion will form. So first of all, what will be the product? Now see here, the product will be CH2, okay, C double bond O, this becomes your CH2 minus, okay, and this is your CH2, CH2, and this one is here, this is your C double bond O, यहाँ पे जो आपका था C double bond O, this is your C double bond O, and this is CH3, okay. So this is the formation of enolate. Now what happens in the second step? वहाँ पे क्या हो रहा था आपका? वहाँ पे भी आपका जो enolate ion, that carbanion ion, that will attack the carbonyl carbon. Here also same thing happens. The carbonyl carbon will attack the enolate ion will attack the carbanion ion attacks the carbonyl carbon, and here this goes to this position, okay. Now see here, what will be the product form? Let's see here, what will be the product form? It is your CH2, C double bond O, single bond CH2, okay. Now this one is your what? This is your CH2 single bond CH2. Okay. Now see here. Here what happens when this bond goes to this position means there is a C here. There is a bond occurs between these two. Okay. And now to see this carbon, one CH3 molecule is attached and here one O minus. Okay. Now after the formation of this compound, again we will one proton that means it will be treated with water molecule H2 and it will take a proton. The O minus will take a proton and it forms OH. So the product is here CH2 C double bond O single bond CH2. This one is CH2 CH2. Okay, CH2 and this one is C. There is a bond. This becomes your what? CH3 and this becomes your OH. Okay. Now next what happens? Here already OH is there, H is there. Again we will heat this compound. When you heat this compound, there is a water molecule removed. So how the water molecule will be removed? Now see here. In this case what happens? The hydrogen which is attached to the carbonyl carbon. Here the hydrogen which is attached to the carbonyl carbon, that goes as H plus and this goes as OH minus. If I write the compound, see here, if the compound is CH2, if I write the compound is like this, okay, if I extend the hydrogen HH this, if I extend the hydrogen HH this, then this becomes H plus, the bond will goes to this position and the OH minus will go to this position. Okay. So now see here, what will be the product? This is your CH2 C double bond O single bond. This one is your CH. Here there is a double bond C to which another CH3 group is attached, and here there is a CH2 group, right? How many CH2 groups are there here? CH2, another CH2 is there. This CH2. So all total in this compound, how many carbon atoms are there? This is a cyclic compound. How many carbon atoms are there? 1, 2, 3, 4, 5, 6. So it is a 6-membered ring having a double bond and a ketofunctional group. So what is the name of this compound? If I write the name of this compound, it is 1, 2, 3, 4, 5, 6. So the name of the compound is, in 3 position there is a methyl, 3 methyl. Okay, it is a cyclohexane ring, so it is a cyclohex. Now see here, in which position there is a double bond? In the 2 position there is a double bond, so it is 2En, and for ketofunctional group the suffix is ONE, so it is ONE.